Hello friends, I welcome all of you to my channel. I hope all of you are enjoying this monsoon season. As you all know that I tried to give you the solutions of previous year CSIR NET and GATE physics exam. So today we will be discussing a question which was asked in NET June in the year 2012. Let us read the question first. The question is the spectral line corresponding to an atomic transition from j equal to 1 to j equal to 0 states splits in a magnetic field of 0.1 Tesla into three components separated by 1.6 into 10 to the power minus 3 angstrom. If the zero field spectral line corresponds to 1849 angstrom, what is the G factor corresponding to j equal to 1 state? So by reading the question, we can make a guess that it is a question from atomic physics. So for this, let us start with the energy level diagram. Try to understand what is going on. So in the absence of magnetic field B equal to 0, there is a transition from j equal to 1 to j equal to 0 state. In the presence of magnetic field, which is external magnetic field, there is a splitting and it splits into three sub-levels. So now what we will use is the energy for splitting according to the basics of spectroscopy is given by minus times mu dot B, where mu is the magnetic moment. Mu is actually mu z dot B and with minus sign, and here minus it will be given by minus of mj mu b dot B. Here mj is the magnetic quantum number, and according to question mj will be equal to 1 plus 1, and mu b is another constant which is given by the expression EH cross upon 2 times ME, which is nothing but Bohr magneton. Now let us proceed ahead. So in the presence of external magnetic field B, we will also consider Landé's G factor. So we will consider Landé's G factor. So energy term, the expression for splitting energy will become G times mj mu b dot B, where mj is equal to plus 1. So it will be modified to G mu b dot B. Now this is the one expression for the splitting energy. Another thing is, we also know that C is given by lambda times nu, where C is velocity of light in vacuum, lambda is wavelength, nu is the frequency. Now here we can write nu as C by lambda. We will differentiate on both the sides, so we will obtain delta nu is equal to minus C by lambda square delta lambda. Now we will multiply h on both the sides, so we will obtain h delta nu is equal to minus hc by lambda square delta lambda. Now h delta nu can also be written as delta E, energy, and it is equal to, the RHS will remain the same here, minus hc by lambda square delta lambda. Now as we can see that we have two expressions for the energy of splitting delta E. So we will equate these two equations for delta E. We will obtain G times mu B into B is equal to minus hc by lambda square delta lambda. Now we will substitute the values of the constants given here, as we have to calculate G. So B is given as 0.1 Tesla according to question. Lambda is given 1849 into 10 to the power minus 10 meter because it is in angstrom, and 1 angstrom is 10 to the power minus 10 meter. Delta lambda 1.6 into 10 to the power minus 3 angstrom. So we will multiply by a factor of 10 to the power minus 10 meters. Velocity of light C in vacuum is given by 3 into 10 to the power 8 meter per second. H is a Planck's constant given by the value 6.625 into 10 to the power minus 34 joules second. Mu B is Bohr magneton. Again it's a constant with a value 5.788 into 10 to the power minus 11 mega electron volts per Tesla. This mega electron volt can be converted to simple joules by multiplying with the factor 10 to the power 6 into 1.6 into 10 to the power minus 19 joules. So we have converted all of them in the standard SI units. After that, as we have to obtain the value of G, we will substitute all these values into this expression. After solving them and calculating them, we will obtain the value of G is 1.857, which is approximately equal to G is 1. So this will be our required answer. So I hope friends you have understood the solution for this question. Thank you.